Welcome everyone, and in this video I'm going to talk about acid-base reactions. And just to give you an overview of acid-base reactions, the first thing that I want to do, I want to define what a base is. The first thing I will do is to define base, give examples of bases, give examples of bases, and also introduce acid-base reaction. Now, to begin, I'll start by defining what a base is. And just the way I did in the last video when I was talking about acids, I want to define a base in relation to two guys who did the definition, Arrhenius and Bronsted and Lowry. Bronsted, Lowry definition. Now, according to Arrhenius, an acid, a base, sorry, is any substance that ionizes in solution to produce hydroxyl ions or the OH ions as the only negative ion. It is any substance that ionizes in solution to give us hydroxyl ions. According to Bronsted and Lowry, the two guys, these two guys defined a base as a proton acceptor. As a proton acceptor, meaning it is any substance that accepts hydrogen ion. Now, examples of bases. Examples of bases. Most bases are formed when metal oxides of group 1 and group 2 dissolve in water. Now, I can have a situation whereby I'm having an oxide of group 1 and, for example, lithium, when it reacts with oxygen, lithium is going to give me lithium oxide. When I decide now to dissolve lithium oxide in water, I'm going to have lithium oxide plus H2O. I'm going to form lithium hydroxide. Now, remember initially I balanced this by putting a 2 here. No, sorry, I can balance it by putting a 2 here to make oxygen 2, then a 4 here. Now, when I want to balance this, the lithium hydroxide formation, oxygens are 2. I need to make oxygen to the other side. I'll simply bring in 2. Yeah, 2 will fit in. So lithiums are 2, oxygens are 2, both sides, hydrogens are 2. I can bring in another example. Sodium, solid. When it reacts with oxygen, I'm going to form sodium oxide, Na2O. When now I want to change and form an hydroxide, I'll take the Na2O and dissolve it in water. Then I'm going to form sodium hydroxide. When I want to balance it, I'll simply bring in a 2 again here to ensure that that is balanced. Now, this one is a base. This one is a base. I can also form a base when a group 2 element reacts with oxygen, then I dissolve it. I can take magnesium plus oxygen. I'm going to form magnesium oxide, MgO. Is a solid, gas, or solid. When I decide to dissolve it, I'm going to take MgO plus H2O. I will form MgOH2. When I form MgOH2, the system becomes balanced. So this one is going to be my base for that matter. So that's how we come up with bases. Now, I want now to go back. I've formed the base. Now, if it was supposed to ionize in solution, I want you now to pick the bases only. If I pick only the bases, I'm going to have this. I'm going to have lithium OH, sodium OH, and magnesium OH. Now I want to justify the proton donor ionization or the Arrhenius and Bronsted-Lowry concept. Now, if this was supposed to ionize in solution, what will we form? I'll form lithium positive plus OH minus. It has justified Arrhenius concept. If this one also was supposed to ionize in solution, I will form Na positive plus OH minus. I've still justified the Arrhenius concept. If this were to ionize in solution, I will form Mg 2 positive plus OH minus. I've justified the Arrhenius concept. But what about the Bronsted-Lowry? Bronsted and Lowry first told us that an acid is a proton donor. And they took the opposite, and here we said a proton donor is a hydrogen. Or proton is a hydrogen, sorry. Now, they went ahead and defined a base as a proton acceptor. Meaning, if you come back to this reaction, if I'm having Mg, OH, for example, then I introduce the hydrogen to it, which is the proton. I'm supposed to have Mg, Mg positive 2 plus H2O. When the proton is accepted, meaning the OH in the base reacts or combines with the proton to give us water molecule. Now this is what is called neutralization reaction. That's what we call neutralization reaction. So now, if I come to acid-base reaction, now if I take my acid-base reaction for this matter, now I come to acid-base reaction. There are key things I want you to analyze and understand before we move deep. The first thing you have to analyze is that when acid reacts with the base, a neutralization reaction occurs. When acid reacts with the base, neutralization reaction occurs. The second thing that you have to know as a student, a base is a substance that neutralizes acid. A base neutralizes acid. The third thing you have to know about acid-base reaction, bases include one, metal oxides, two, metal carbonates, and three, metal hydroxides. The next thing you're supposed to know is that bases have a pH of above 7. Bases pH is above 7. Next thing that you're supposed to know, many bases are insoluble in water. many bases are insoluble in water. Now, those are the key things that you need to know. Now, what is a neutralization reaction? What is a neutralization reaction? A neutralization reaction, for that matter. Now, a neutralization reaction is a reaction that involves an acid and a base. A neutralization reaction involves acid and a base. The reaction between acid and a base, and it yields salt and water as the only product. That's very key about neutralization reactions. But now, remember we said examples of bases include metal oxide, metal carbonates, metal hydroxides. So for that matter, if the base is a metal carbonate, if the base is a metal carbonate, then I will have a situation whereby my acid and the base reaction, because the base is a metal carbonate, will yield salt plus water plus carbon dioxide. Now, if the base is a metal carbonate, the base is a metal carbonate, then carbon dioxide will also be produced. Now I'm going to write that question. It will be acid plus a base, which is a metal carbonate, will yield salt plus water plus carbon dioxide. Salt plus water plus carbon dioxide. Now the third thing you need to know, the third concept you need to be well conversant with, the identity of the salt formed in an acid base reaction depends on one, the type of acid used. Meaning, if you use sulfuric acid, if you use HCl, you are going to form chloride salts. If you use sulfuric 6 acid, you are going to form sulfate salts. If you use nitric 5 acid, you are going to form nitrate salts. And lastly, if you use phosphoric acid, you are going to form phosphate salts. Now, the key thing you need to know as a student is that the type of acid used will determine the type of salt formed at the end of the day. And the second thing that determines the identity of salt, the second thing that determines the identity is the positive ion in the base. The positive ion in the base. The positive ion can either be a group 1, can either be a group 1 or a group 2. Group 1 we have lithium or sodium or potassium. In a group 2 we have magnesium or calcium. So the type also determines, the type of positive ion also determines the identity of the salt that will be formed. Now, let us now see how various reactions happens between acids and the 3 neutralization reactions we have. Now, here, the first one we are going to deal with is reaction between acids with metal oxides. And here I'm going to do various examples so that you can see whatever thing that is happening. Now, imagine a situation whereby I'm reacting sodium oxide with sulfuric 6 acid. I will form sodium sulfate plus water. Now, if you look at that given reaction, you'll realize that the reaction is balanced. There's nothing you can do to balance it. It is already balanced. Another example can have HCl reacting with copper oxide. I will form copper 2 chloride plus water is H2O. Now, hydrogens are 2, chlorines are 2. I simply put 2 here and the equation will be balanced. The next one that I'm going to do is the reaction between magnesium oxide and sulfuric and nitric 5 acid. So imagine when I'm having magnesium oxide plus nitric 5 acid. I'm going to have magnesium nitrate Mg in bracket NO3 2 plus water. Now if I decide to balance the equation, it's very easy and simple to balance. Don't need to worry. Let us look at magnesium. Magnesium is 1 on the reactant side. It is 1 on the product side. Oxygen. Now let me go to nitrate. Nitrate is 1. Nitrate these sides 2. I'm generalizing them. Hydrogens are 2. Hydrogen is 1. Oxygen is 1. Oxygen is 1. Now, what I'm going to do to ensure that the equation is balanced, very simple. Simply have to add a 2 here, then the whole thing will be balanced. It will be as simple as that. So this one is a solid, aqueous, liquid, liquid, aqueous, solid, aqueous, solid, aqueous, aqueous, liquid. It is going to be as simple as that. Next is a situation whereby you have a reaction between acids and metal hydroxides. Reaction between acids and metal hydroxides. Now, in such a scenario, the hydroxide is what is going to be the base here. So if I want to do an example, I'm going to treat the bases that I gave you before. For example, I can react hydrochloric acid aqueous with lithium hydroxide. If I do so, I'm supposed to form lithium chloride plus water. Aqueous liquid. Can try another example. Sulfuric 6 acid reacting with sodium hydroxide. I'm going to form sodium sulfate plus water. So to balance it, hydrogens are 2 that side, hydrogens are 3 this side. So what do I need to do? I need to look for a number that when I put somewhere it's going to order everything. So I can decide to put a 2 here. Hydrogens are 4 now. How do I make hydrogens this side 4? By simply putting a 2 here. So hydrogens are 4. Then if you look at it very well, you realize that it is balanced by just doing that. Next, I'm going to have a situation whereby the next thing we are going to handle is now reaction between acids and metal carbonate. Reaction between acids and metal carbonates. Previously, we said that when an acid reacts with the metal carbonate, we are going to form salt plus water plus carbon dioxide. Now the added thing in salt and water is just carbon dioxide. I'm going to do 3 examples in this case so that we can see what we are dealing with here. Now, if I react HCl plus sodium carbonate, the product should be sodium chloride, which is a salt, plus water plus CO2. How do I balance such? If I want to balance it, I simply put a 2 here and another 2 on the HCl because I'm only interested in balancing. I'm only interested in balancing. The hydrogen, sodium, and chlorine. Now next, it's going to be a carbonate of calcium, which is a group 2, reacting with sulfuric acid. So I'm going to have H, so 4 aqueous plus calcium carbonate is a solid. So what do we do here? We are going to form calcium sulfate, Ca, now how do we balance this? When I want to balance this, simply look at hydrogens are 2 here. We have 2 hydrogen, sulfate is 1, sulfate is 1, calcium 1, calcium 1, oxygen 3, and oxygens are 3. Carbon is 1, carbon is 1. So it is balanced. The last example I'm going to do. The last example is going to be nitric 5 acid reacting with magnesium carbonate. I'm going to form magnesium nitrate plus water plus CO2. When that happens, we are going to balance it. So when you want to balance it, The only simple thing we are going to do here, just adding a 2 here, balance the hydrogens, which are 2 on the other side. Then nitrates are 2, we will also balance nitrate. Then the equation is balanced. So those are the key things you need to know as far as acid basis reactions and neutralization reactions are concerned. Thank you very much and have a wonderful